Ratios and proportions are important. If you double the amount of reactants, the amount of energy released doubles. First is the original, and then what it would look like if you doubled everything. So take a look here. We have the original problem. We have 2 hydrogen, 1 oxygen, and we have 2 water. There's also the delta H here, the enthalpy. It's on the product side, which means that energy is lost. Now let's say that we wanted to double this, all right? This means there's 2 moles of hydrogen gas and we're producing 2 moles of water. Well, what if we want to produce 4 moles of water? How much energy would be given off? So let's take a look at the intermediate. Here we can see we did double everything, and you have to double the amount of energy as well. So I showed it with the little 2 and then the multiplication sign in there. This would be the final one. Here we have numbers doubled as well, and the amount of energy is doubled. Let's try a problem where our goal is to determine the delta H. So it says, find delta H for the following reactions. Use the equation delta H reaction equals delta H products minus delta H reactants. I know. It looks like we went from 0 to 100 real fast. First up, let's talk about the problem. Let's see what it's asking for. First of all, we're looking for delta H with this little prime, this little 0 up here. For this year, don't worry about the prime. It doesn't make a difference for us. The equation is basically the products minus the reactants. The other thing that's new is there's a capital sigma, which looks like this E here. That means to find the sum. So find the sum of the products, then find the sum of the reactants, and then subtract. Here's a condensed version of the chart. Notice it has other variables besides delta H. As you can see here, we have delta G, delta S, which we haven't talked about yet. So just focus for now on the center, and I highlighted it for you. When you're asked to calculate them, you do the exact same thing that we're going to do for delta H. All right, it's still going to be products minus reactants. Here's our equation. We have 2 KBr plus 1 H2SO4 yields K2SO4 and 2 HBr. Now, all you have to do is substitute the numbers in the chart instead of having the molecules. So for example, KBr is found here in the chart, and its number is negative 392. Which is why we have negative 392 here. H2SO4, if you look in the chart, that's also negative 814. K2SO4, that's negative 1409. And then HBr is negative 53.4, which is where we get this number. The only other thing that you have to take into consideration is the coefficients. So if there's a 2 there, you multiply by 2. If there's a 3 there, you multiply by 3. If there's nothing there, you don't multiply it by anything. The next thing that we're going to talk about is these are the reactants and these are the products. We need to do products minus reactants. So we need to flip their positions, which I'm going to do on the next slide. Okay, so this is the slides we just saw. I highlighted the parentheses so we can see them a little bit easier. And also the numbers are still in there. And how we're going to do this is we're going to switch the products and the reactants. So now we have the products over here, we have the reactants over here, and then you're just going to add up the products, which is why we have these parentheses here, because you're going to do all of this first, figure out what the number is. Please put it in your calculator, give it a try. You should get negative 1,515.8, and then you're going to do the same thing over here. You're going to multiply these together first, and then you're going to add negative 814, and then you should get negative 1,598. And then when you do this problem, because remember it is products minus reactants, you'll get 82.2 kilojoules per mole. And again, throw it in your calculator, make sure that it works, and then realize we have to figure out sig figs as well. All right. If you remember adding and subtracting with sig figs, you had to go to the least number of decimal places. And some of these numbers, they don't have decimal places. That would be going to 0 decimal places or a whole number, which is why the answer should be 82 kilojoules divided by moles. All right, and that should be the answer for that one. It's not a hard math problem. It's just there's a lot of weird little things you have to do. Try this problem on your own. Let's see how you do.